Alright, so we are in Algebra 1. We're doing our lesson that we should have done at the beginning, 9-0. Next year will probably be called 9-1, so I'll add it in correctly. Today's date is Thursday, March 12th, 2020. We're talking about the language of polynomials, how to talk about these things to your peers, to your teacher, etc. So, our objective today is to... Ozzy?
Talk about cards and properties of polynomials.
Thank you. I'll take your card. Alright, so most of these terms we've already defined. I have not defined degree yet, but these should sound really familiar. They're the almost exact same notes that we had from 9-1. So, a coefficient is a what that is being multiplied by a what? Who has their card? I'll have a backup for Charles. A coefficient. Jay, do you have your card? Yeah, I'll take it. A number being multiplied by a...
Exponent.
You had it right the first time. It is a variable, yeah. Thank you, Jade. I'll take the card. Charles is already ready to go for the next one. A variable.
A number. That we don't know yet.
It is indeed a number that we don't know yet. All right. I need someone new. Who has their... Oh, what's up?
Yes. It's 9-0.
Um...
Is it like that? Yeah.
Yeah.
Oh, it is.
Because we were supposed to do this lesson at the very beginning.
Oh.
It's my bad. I'm trying to go back and backfill. Because otherwise you'll see the test and you'll be like, wait a sec, we never learned any of this. What is a binomial, like with a degree of 5? Yeah, so our knowledge will improve. A constant. Emma. It is indeed a number with no variable. And before we jump too far, I will call on Wyatt for the next one. Let's start labeling these things up here. So again, 3, -2, or if you just want to say minus the +2, whichever one you want to say, and 7. These are all coefficients. So I'm going to write down coefficients. I can't spell, even though it's right underneath me. Coefficients. And then our variables. We know that x is a variable, so that's a variable. I'll just write var. X, all of those are variables very clearly. I think we learned that at least in 8th grade, if not 7th grade. And then the only constant that we have, there's only one of them, and it's 17. 17 is the constant. So one of the mistakes that I used to make is saying, oh, this 3 is a constant because it's a number. If I ignore the x to the power of 4, yes, it's a constant. But it is attached to x to the power of 4, so 3 is not a constant. 3 is only a coefficient. There's only one constant, and that's 17, because that is the only number that does not have an x next to it. Moving down, a term. Yes, Wyatt?
Numbers and/or variables separated by a plus and minus.
Plus and minus. There it is. Plus and minus. Thank you. So you kind of have different segments, right? So I consider this was a variable, this was a variable. Let me come back here and finish these. So each of these chunks is a term. So that 3x to the power of 4 is a term. This 2x to the power of 3 is a term because it's separated by this minus sign. This 7x squared is a term. This this x is a term. This 17. All these are chunks of the polynomial, and I call those chunks terms. All right. And then let's talk about a polynomial. It's a collection of one or more. Yes, Eamon.
Terms.
Terms. There it is. Thank you. And again, it's a weird way to define a polynomial, and I'm sure that mathematicians might not all agree on this. Maybe some mathematicians say a polynomial is a collection of 2 or more terms. This is the way that I'm defining it in my class, which means the number 2, just 2 apples, right? The number 2 is a polynomial. It's kind of weird to think about, right? 5 is a polynomial. -7 is a polynomial. We have to kind of redefine what we think of in terms of polynomial, maybe. All right, and then finally, a new term, a new arrival. So a degree. Anyone want to take a yeah, this one's going to be hard. I'm going to, oh yeah, go for it, Charles.
Maybe like the power, like of a variable.
It has to do with the power. So I'll use the word power here, or you could use the word exponent, either way. And it's actually the highest power, or the biggest power. I'm going to write biggest. The biggest power of all of the terms in the polynomial. And I'm going to put in parentheses here because I'm realizing this is not 100% the perfect definition. It's the highest, this is the biggest power of the variable. And it is talking about the polynomial. So for an example, let's go up above. I'll let you guys finish writing this down. So it's the biggest power for that fill in the blank, and not the very end of that we said of the variable. The largest or biggest power of the variable. So if I come up here to our polynomial, this is my polynomial, and it has, okay, I see a power of 4, I see a power of 3, a power of 2, a hidden power of 1, and this is actually a power of 0 because there's nothing. This is a degree 4 polynomial. Why? Because the biggest power was 4, so this entire polynomial is degree 4. Question?
What did you mean of the variable?
So if I, for example, had 3 squared, x to the power of 4, or 3 to the power of 7, x to the power of 4, what degree is it? Well, even though this is a 3 to the power of 7, I only care about the exponent of the variable.
Oh, I see.
All right, yeah, that was a great question. So, and do I ever talk about standard form in here? If I don't, I need to talk about it now. I don't. Okay, so I need to talk about it now. What is standard form? I guess it's something that I could kind of add underneath. I'll call standard form. Standard form. And you've been seeing this over and over. I think the first homework assignment is like, make sure your answer's in standard form, and I never talked about it. But now that we have formally defined what degree is, I can define what standard form is. Standard form is how you write the polynomial. So notice up here, this polynomial has, and I can talk about degrees of each individual term and degrees of the entire polynomial. So the degree of the entire polynomial, as we said before, is degree 4. But I can also say this term, this chunk, is degree 4. This chunk, this term, is degree 3. This term is degree 2, this term is degree 1, this term is actually degree 0, and then I can arrange them highest degree to lowest degree. Notice how it goes 4, 3, 2, 1, then 0. So it would be incorrect to switch these two. That is no longer in standard form. If I switch any of these, it's not going to be in standard form. It has to be highest degree all the way to lowest degree, highest degree on the left. So that's essentially how I'm going to define this down here. Standard form is highest to lowest degree. And by default, for the rest of your college and high school, everything mathematical experience that you have, list all of your polynomials in standard form unless it explicitly asks you not to. And there are some weird things on Khan Academy. Sometimes they allow you to not write the answer in standard form, and you've already seen one of those. So I'll give you an example over here off to the side. Remember when we did we did like 7 minus x times the quantity of 7 plus x? This is a type of problem where Khan Academy is okay with you not listing it in standard form because it makes more sense to not do it in standard form. Because, does anyone remember how to multiply these really quickly with our shortcut? Only 2 people know the shortcut? Oh. 3 people, 4 people, 5 people. Do any of those people have a card? No? Who does? Asha?
Yeah,
Oh, yeah.
Well, I have my card, but I should have turned it in.
Oh, okay. Well, you can go again and then turn in now. What is...
Okay, so the shortcut would be 7 squared.
Exactly, which is?
14.
Ooh, careful, that's 7 times 2.
No, 49. 49. I
49?
always get that wrong.
You're good, you're good.
49, and then x squared
X squared, and what sign goes in between?
plus.
Ooh, careful. It's always 100% of the time the other one.
It's always subtraction?
It's always subtraction because if it's a conjugate pair, this one will always be a minus sign, this one will always be a plus sign, or vice versa, and a positive times a negative is always a negative. And then the middle terms cancel out, that's why there's no middle term right there. Yes, Wyatt?
Is it easier to write it that way instead of not in standard form? Because if you wrote it in standard form, then you would have had to write more, because it would have been negative x squared plus 49, so you would have just had to write an extra.
Yeah, you'd have to go like this, negative x squared plus 49, as you said. So this is now in standard form, but this is the one case that I know of on Khan Academy where it allows you to write it in a non-standard form because it makes sense. Yes, Kier?
49 doesn't have a variable, and you said we only care about the exponents of variables, so.
Precisely, yeah. But if I come back up here, I should probably label this in the notes for all of us. We should label the degrees of each of these terms. So I'll write up here, this is our degree. So up above 3x to the power 4, that has a degree of 4. Because, as Kira said, you talked about the power, the exponent, it's 4. The degree above 2x to the power 3 is to the power 3, then 2. And then there's a hidden 1 here. Whenever you don't have any power, you assume that it's a power of 1, so this is a degree 1. And the very hard, I guess the hardest thing to label is that this is actually a degree, and the degree is 0 because I can do a hidden x to the power of 0. Why am I allowed to do that? Someone tell me. Why am I allowed to say x to the power of 0? Why?
Because
what is drawing a blank now?
I put too much pressure. I should have given more think time too.
Why? You're just like blank.
What is anything to the power of 0 win?
anything to the power of 0 is always 1, and 1 times anything is itself. So.
Yeah, thank you, Wyatt. Yeah, so it is technically a degree 0 term, even though there isn't a variable, because we can imagine that hidden, it's like a super hidden variable, right? The hidden power here is 1. This is a super hidden power of 0. And that's why it's a degree 0 term. So technically we're writing a degree 2 term and then a degree 0 term, which is in standard form now. All right, so let's talk about some special names of polynomials. And they're really fun names too. Well, I think they are. You might disagree, but so if I have a degree 0 term, that is called a constant, and that matches our definition above. So I'll write this, constant. Why does that make sense? Well, we've all seen that in our hidden, I'll let this be up here so you can write this down. We all saw that up in our polynomial up above, this was a degree 0 term. Any degree 0 term will not have any variable, and by definition, a constant is a number with no variable. So that's literally a constant. If I give you the equation y equals 1, that is a constant function. A degree 1 term, and we've been studying these at the very beginning, like, I don't know, in August of Algebra 1, those are called linear. And you can probably see the word line there. That means if I had an equation that had a degree 1 polynomial, that's like x minus 7 or 3x plus 5. Those are lines that you're graphing, and they are called linear functions. They have a maximum degree of 1, and then we're just going to keep building off of that. What happens when we have a degree 2? We haven't seen it yet, and that's what this whole unit is about. Unit 9 is about degree 2 terms mainly. And these are called quadratics. Quadratic. And you might be looking at this list and you're saying, I shouldn't touch my face. Fake stroking the beard. We did exponentials. So where are they on this list? Exponentials have a variable in the exponent instead of a power in the exponent, so they actually don't go on this list. Nor do logarithms and a bunch of other things. A degree 3, does anyone want to take a guess at degree 3? No? Question, Kira?
Yeah, I'm a little confused. So degrees are not the same as exponents?
They're basically the same as exponents. The highest exponent.
Okay. So if 2 was the highest exponent, you'd be like, oh, it's quadratic.
Yep, it's a quadratic. So up here, this is it's a degree 4. But if I could hide, if I scribbled out these, I would say, oh yeah, this thing with 3 terms is a quadratic. But it's not because it has bigger exponents. And then degree 3 is called a, oh yeah, Wyatt, go for it.
Can I take a shot at it?
Yeah.
Is it a cube?
Oh, you're so close. It's cubic.
Cubic.
Yeah. Cubic. And then that's from the word like to the power of 3 means cubed. So. And then you do not need to know 4 and 5 for Khan Academy ever, but I thought I'd throw them in here just in, well, do you? I don't think you ever do because they call these degree 4 terms. So officially I'll put the Khan Academy one here. I call this a degree 4 term or degree 4 polynomial. And then this one is degree 5. But they do have actual names. At least a degree 5. I don't know if degree 6 has an actual name or not. I know them for 4 and 5. But yeah, anything above 3, so 4 and above, on Khan Academy, just call it degree, whatever the degree is. These are called quartic. Oh, am I going to spell this right? is it C or QU? I'm going to guess QU. Quartic and quintic. But I am not sure if I'm spelling that right. I'm going to freeze the screen and Google these real quick. Is it quintic? It is quintic. I got it. And what about quartic? Quartic? Boom! All right. Good guesses, Mr. Sindel. All right, so those are the only ones that you'll ever be seeing in my class. And then, well, at least in Algebra 1. And then over here, the number of terms. Yes, Charles, before we do that question.
If, let's say, like, it's a binomial and it has, like, a degree 0,
Yes.
would it be a constant binomial?
Yes. Well, it's impossible to have a constant binomial, unfortunately.
But you get the idea.
Yes, exactly. Oh, you're already doing the examples. Nice. So if I have a certain number of terms, that's also going to have a special name. So if I have degree 1 term, that is called, we learned it already in lesson 9-1, 2, no, it's 9-2. Wyatt?
Monomial.
Monomial, yeah.
Monomial.
I can't spell. Monomial. That's a recurring theme in my life. I just don't know how to spell. Or maybe that's me having a fixed mindset when it comes to spelling. I'll just make errors and I'll learn from them.
I wonder if there's a math spelling bee where you have to spell a bunch of like.
Spell
numbers.
quaternion. Don't touch the paper. Spell quaternion, yeah. Number 2 terms. You guys know this. Oh, yes. Hold on. Are the people with cards out? I still need to get people with cards. Hugo's trying to hide his card. You guys know these. We've talked about them before. These are kind of easy ones. Ulysses, are you in?
Yeah.
Okay. Who's not in? Is it Larissa, Hugo? Yeah, Larissa. It is a binomial. And just like a bicycle, and then if I have 3 wheels, Hugo, it is a trinomial. I really feel that one should be called a uninomial, like a unicycle. All right, example 1. Let's name this guy. Is his name Bob? Is his name Jordan? What is his name? What is his name? Jade's been waiting so patiently. Yes, Jade.
Quadratic monomial?
It is almost a quadratic monomial. It is definitely quadratic.
Binomial.
Binomial, there it is. Why is that a binomial and not a monomial?
Because there are 2 terms.
There it is. Yeah, there are 2 terms because terms are separated by a minus sign, so 2 terms, and it's quadratic because why again? Why is it quadratic, Jade? Where'd the word quadratic come from?
Because it's to the power of 2.
Yep, that's the highest degree, and the highest degree 2 matches up with quadratic. Let's try example number 2. What is the name of the following polynomial?
I don't want to find out.
Is his name Steve?
Yes.
It's not. No, it might be.
Might be my brain.
Is it numberist of me to assume that his name is not Steve? Wyatt, yes.
Is it a cubic trinomial?
It is indeed a cubic trinomial.
This is like speaking another language.
I know, it totally is. And it's kind of cool to be able to speak a language that maybe most adults can't speak. Yes, Kira, you're going to do the last one?
No, I was just gonna say, on the last one is 2 and 2, like, the number was 2, and there was 2 terms, and then the number is 3, and there's 3 terms.
That is totally a coincidence. And this one is also, this one's going to be 0 and 1 instead of 1 and 1, so it'll be a little bit off. Yeah, Charles, go for it.
It's a constant monomial.
There it is. Constant monomial.
Is that literally all of what the homework is?
That's what the homework is, and it's more multiple choicey and selecting things instead of typing it in because typing and spelling things is hard, and it's nothing that I should ever assess you on. If you ever have a teacher that says, you didn't spell binomial right, -1 point, I will cringe because I don't really care about spelling. I care about the logic. It is nice to be able to describe things, so that's why I'm doing this lesson. All right, can you guys give me the fist of 5? How well can you use our language and talk about polynomials to your friends, to your teacher? 4, 5, 4, 4, 10, 5, 5, 5, 4, 5, 4. All right.